All right, so for the warm-up, we got two problems. For what value of b does the integral, right here, this integral, equal to this limit definition of a integral? What would be the value of b? Why? Anybody, why would it be what you think it would be? Yeah? Why?
Because the 2 over n means that the difference between two numbers is 2.
Okay. And so what are you doing? You're just adding 1 plus the 2 equal b. So in more than that also, what else? Is that this is the lower limit, wouldn't that be the lower limit, no? So it would be what? The lower limit or the upper limit minus the lower limit? Would this be a good statement too? Is equal to 2, maybe something like that, but in any case, that's how probably they would test this, something like this on the AP exam. Will be a multiple choices, maybe, if they do something like that, no? But yeah, okay, let's go to number 2. What is the value of that integral from 1 to 5 f of x dx? So the area under the curve of the area under the curve from 1 to 5, no? So say you graphed it to find the area under the curve from 1 to 5. It is defined to be equal to 2, no? F is defined to be equal to 2 for x less than 3. X less than 3, it will equal to a constant. And for x greater than or equal to 3, it'll be with the slope, a line with the slope, goes through a negative 1 right here somewhere, and then it goes up 1 over 1. So it will go up 1 over 1. And you get something like that all the way to 5. Let's go all the way to 5. So it's there under the curve. And between the x-axis and this thing, we're trying to find this area here. What that area here is, and that area, that is what's the area? This is what? This is a rectangle. That would be what? 2 times what? 3? Is that 2? That would be what? Is that 6? And this is a trapezoid. What was the trapezoid formula? What was it? Base times what? H1 plus H2 over 2, was it? Is that what it is? And so the base is what? If we do that, base is 2. And then what? H1? 2 and plus 4. 2 plus 4 over 2, so it's 6. Oh no, I don't know about that. I knew it was like there's something wrong. It's going from what? Lower limit is what? I went all the way to here. So the answer, I knew there's something. So the lower limit and upper limit matter a lot. You can't just be going anywhere you want. So lower limit, we're talking about lower limit, upper limits here, 1 and b. So from lower limit to upper limit, area under the curve in between the function in the x-axis. No? Did I even get that one wrong? Did I say it was 6?
It is 6.
It is 6, is it?
I think if you click one more time, you'll probably have a 2 up there.
Ah.
Maybe.
Okay, I'm like, why are you laughing at me? Man. You think that man. It's 10? Alright, so what is it? Be very careful about lower limit, upper limit between where and where. And that's good. Alright, let's go to the lesson for today. And this is actually one of the most important lessons because it incorporates more and more the concepts of the first semester with this new concept of integrals and how they are inverses of each other and how they are related. So we had said that g of x is an accumulation function that depends on the area under the curve of f. And so what we could do is this. I don't know if that's what I did when we first started 6.1, where if we make this statement that g of x is equal to the area under the curve from a to x of f dt, f of t dt, we take the derivative of this, the whole thing, d dx. So if we take the derivative of g of x, that becomes g prime of x. That becomes g prime of x. And what we do is we input this x into t. So then that becomes g prime of x will equal to f of x. G prime of x is equal to f of x. So g prime of x is f of x. Oh, I didn't update it. Let me get out and update this. Exit. All right. So sketch a rough graph of g, where g of x is equal to that. And we already did this same function in 6.1. I think I remember we had done this, where we did all the accumulations starting from 0. And what we're going to do now is that this is let's see, the velocity. If we could continue on talking about, oh no, it was already and take. If we just kind of talk about that this is a velocity function, say this is v of, okay, let's stop there, there's v of something. This is g of x. Let's say this is g of x. That's for sure, g of x, because that's what this is, g of x here. And we're saying g prime of x is equal to f of x. G prime of x is equal to f of x. F of x. Okay, let's continue now. Let's make a table of values here for it. And now you ask, well, what should we use as table of values? Well, it's going from 0 to 7 here, this velocity from 0 to 7. Let's use these points here, no? Let's use these points here to graph G. All right. let me give you a little bit more time, 3-4 minutes to copy this down. This is important. I don't want to hurry it up like I usually do because this is very important. I am pretty sure that they really will try to test, they will test this on the AP exam. All right, we already did this before, no? So x is equal to 0. X equal to 0. We're going to plug it in here. 0. So there's no area accumulated. If it's going from 0 to 0, we're right here. There's nothing. So then this should be 0 here for this one here, no? And this is 0. All right? All right, we're there. That's the relationship. The area under the curve is what G will be. The Y value on this G graph. So let's go to 1. X is equal to 1. We go here and find the area under the curve here. What's that area under the curve? 1/2. So that is 1/2 there. So this is 1/2 here for G. So X is 1. For X is 1, we will have 1/2. 1/2. For x equal to 2, what's V? No, well, we're plugging in here now. Again, as we continue on from 0, x is 2 here for this function here. This is what we're looking at, the relationship. What's the area under the curve from 0 to 2? What's the area under the curve from 0 to 2? Is 0 because the positive and negative cancel out. So that is, it should be 0 for this G function. And we add 2. At x equal to 2, we're going to put a dot right there. And we continue, and we've done this one here before. From 0 to 3 on the area under the curve of f. This is 3. What is that now? From 0 to 3? From 0 to 3 all the way there, what is it? -1/2. Because these two canceled out, this is -1/2. So here we go to 3, is -1/2. And when we go to the G function, we go to 3 to -1/2. Then we continue, as we continue on with accumulating 4. So what is the G of 4? This is 4. From 0 to 4? What is it? 0. So this is going to be here 0. And now we went back over here. uh, no, V of 5, am I saying this? Yeah, V of, the area under the curve better, don't, let's go with saying F, the area under the curve of F from 0 to 5, that is best said. The area under the curve of F, from 0 to 5, area under the curve from 0 to 5 of F. Okay, that's better. So these cancel out. These two added can do with that. We just want to know this now. What is this? What was that? Trapezoid? No, is it a trapezoid? Is it a trapezoid? Okay. So I don't usually use the trapezoid formula, but what is it? The width is 1 times the, what is that? H1 and H2 added up, no? So it'd be 1 plus what? 1 plus 2? Is it? Oh, because couldn't you just do that? This is 1 and then 1.5. I don't know. I like looking at it like this better because it's 1.5. Duh. Okay. In any case, 1.5. So for G of 5 is 1.5. 1.5. So to find what 6, this whole thing already accumulated and it's positive and it's negative to 1.5. So to 1.5 we're gonna add this thing here, and this one I'd rather go ahead and do what's the answer without doing that? 2.5, isn't it? 2.5 plus 1.5 would be 4. So this is 4. So 6 goes to 4. And now we're going to just kind of guess what this is. What does it look to be like around? I don't know. It's just a guess, no? Couldn't we just kind of guess it? If I go like this, that's straight like that. That's definitely 3. If this is a rectangle, 3 times 1 is 3, 1.5, and I'm just gonna put a little 2. Let me say it's 2. All right. So let's. It's a guess as to what that is. Say it's 2. So 2 plus. Oh, am I guessing right? Probably more than that. No, 2.5. It's a guess as to what would that be. And let's say it's 6.5. So all the way to 7, it goes to 6.5, something like that. And so this is the relationship between the area under the curve here and G. So the area under the curve of F is the distance traveled. If you talk about distance traveled, no, where G is position, no, and this is kind of velocity, and the area under the curve of velocity gives you how much distance you've traveled. Okay. Now that we've done this, how are they related in terms of when G of X has something? It's because when F of X is doing this something else. Go ahead and you don't have to be copying this graph down, of course not, these two graphs, because you already have them. Write this down right here, the table maybe behavior of accumulation functions. G of X is increasing. If we're talking about G is a position function, and if if g is a position function, it's increasing means that it's doing what? I don't know. They usually talk about a particle is moving along the x-axis, horizontal x-axis, and let's say that the particle is at position, starting position of t equal to 0 is right here. Particle is a little card here. All right. So increasing means what for the car? If this is x's position, no? What does increasing mean? The g of x is x of t is g of t. G of x, I mean. Position g of x, we're talking about this g of x. Okay, what is it doing if it's increasing? When f of x is doing what? When f of x is what? When f of x is what? Let's see. F is what? When f is positive. When f is positive, is that what we want? When f is positive. G of x is increasing when f is positive. Is that another way of saying that f of x is greater than 0? When f of x is greater than 0, okay. It is decreasing when f is what? So when f of x is less than 0? Here's another way, no, when velocity is positive, no, when the velocity is positive and then decreasing when velocity is negative, whatever. Okay, moving on. Relative max. G has a relative max when F what? Relative max. What do we say here? G has a relative max when does G have a relative max in relation to F?
When f of x changes from positive to negative.
Okay, so let's see. Yeah, let's see. Well, you notice that it would have what you just said, no? It's right here, when positive to negative. Yes, right here. And this is this right here. Because we went from positive to negative. F of x changes from positive to negative. So relative min would be where?
3.
Because why?
It's changing from negative to positive.
F of x changes from negative to positive. And so here's where you need to remember, well, it makes a lot of sense looking at that. Well, it's a relative max we talked about, remember? So it's a relative max of this would be here, of course. and it's a relative min of it here for this position function. Yeah, it makes sense. That one's new of looking at it with area. Concave up. G is concave up. I don't know. Well, we'll go look at that in a minute, but I'm going to look at this. This. What is this? What is this? Concave down. Concave down 0 to 2. From 0 to 2. Not the area, but this thing is maybe. What is that? The slope of f is negative. But that's not what we want. We want concave up, no? So concave up would be concave up. Well, we already know this concavity. Hopefully, we did this concavity. That's for sure is concave up. And concave up all the way, if this is true, all the way to 6, this should be somewhat, it should be more like this. This shouldn't be like what it has in the graph. It should be more like that, no? If it's, so this is concave up, is when this has a positive slope. The velocity, the slope of the velocity is positive. And so what are we going to say about concave up? Concave up is when what?
F of x has a positive slope.
Okay. Hold on here a second. What is it? Oh, concavity here. Let me see. What is all that? F prime of x is greater than 0. The slope of f is greater than 0. Is that another way of saying the same thing, no? The slope of f is greater than 0. It's concave up. And concave down would be what?
F prime of x less than 0.
So for what this says, so if to follow it, f prime of x is less than 0. It's the slopes of the velocity less than 0. So really pay attention to this, no? When you make for the free responses and whatever, relative max talks about changing signs, and over here it's talking about f prime of x is being greater or less than 0. Anyways, let's go with a point of inflection. So G has a point of inflection. Where does G have a point of inflection? Huh?
That's it.
2. Why is it at 2?
F prime is equal to 0.
What is it?
F prime is equal to 0.
Here? Are we going to say that f prime is equal to 0? Is that a good... Well, but what's the reason why though? Wouldn't this one also be 1?
F prime of x changes sign.
Huh?
F prime of x changes sign.
Yeah, that's what I'm talking about. That be careful on that. It's a 0 or is that a point of inflection happens when f prime of x changes signs. Which is it's a little bit, it's kind of like this one here. It is the same. You could say f prime of x changes from positive to negative, or where it changes from negative to positive, no? That's talking more where This one just says it has to change signs. F prime of x has to change signs. All right, so let's go ahead and do some problems now dealing with this. Here we go. Let's go ahead and do this. Let f be a function defined on this closed interval from 0 to 7. The graph of f, whatever. Let g be the function given by g of x equal to that. So let's go ahead and copy that down. Anthony, what's G of 3? Oh, let's see. G of 3. What's G of 3? What are you trying to do? You trying to do a trapezoidal thing? Man, come on. Man. You don't. Well, you could. Well, if you really wanted to. If you want, what is that? What's that trapezoidal one says? Formula is the base times what? Times h1 plus h2 divided by 2. No. If you wanted to do that one. So you know the base is what? The base. If this is the base. No, it's 1. And then 4 plus what? 4 plus 2, 6, it's 3, no? It's 3. Or you could do the, what is this? What is that? 2? And then what is this? It'll be what? A height of 2, 2 times 1 is 2, divided by 2 is 1 plus 2 is 3. So whichever one, figure out which one you like best, how to come up with it. G prime of 3, what would be G prime of 3? So basically we said that what? If we do take a derivative of this, take the derivative of that, it would just become G prime of x will equal to what? F of x. Because this is the velocity, and we have the velocity graph of that position. And the answer is, what is the answer to that? Who is over there in the back? Next to Anthony. Who's that? Huh? What do you mean you don't know? What is prime? G prime. What's G prime? We said what? Look, G prime of 3 should equal to what? F of 3. F of 3. G prime of 3 should equal to F of 3. What's the answer now? F of 3. G prime of 3 should equal to F of 3. What's F of 3? The graph of F. That is the graph of F. The graph of F here. So what is F of 3? You're just going to it right there. Why? Because graph of F is what? If we're talking about is what? Which is the velocity, and is asking what's the velocity at 3. And if it's telling you that this is the graph of the velocity, it's telling you what the velocity is at whatever point, no? G double prime of 3. G double prime at 3. What did we say in the chart that we just barely did? What did we say that G double prime means? What G double prime of 3 would equal to what? F, but it would be F prime at 3, no? And what does prime mean if you have F? The slope of it at that point, no? So what is the slope there? What's the slope? Rise over run, is it negative 2? Negative 2? Is it concave up or concave down? Is G concave up or concave down? G, concave down, wouldn't it? Because acceleration is negative. Okay. Good, moving on. D, we'll continue on. We did ABC, we're on to D. What are the critical points of G of X? Identify where G of X is increasing and where is it decreasing. Justify your answers. Where's the typo? I was looking for it. Did you actually write down where it? I was. You see that?
Yes. Just had my mind like auto translate GPS, so
You just fixed it?
yeah, I just fixed it itself.
Find the critical points of G of X. Then identify where G of X is increasing. Where is it? Find the critical points. Where are the critical points?
X equals 4 and X equals 6.
Okay. Okay. Now, here's my question. Why is this not a critical point, or why would it be a critical point?
Because it's an endpoint.
Let's at an endpoint. Yeah. But it's still equal to 0, though, doesn't it? It's still equal to 0. Okay, because when we had talked about what was that? Like, say this is G again, and then G is doing this, or whatever, something like that. Okay, and we got maybe say from there to here. What was that here? Where is it? This is a relative max and relative min, so we would be testing these internal points, but also the endpoints are critical. It's equal to 0. That's a good. It's equal to 0. Wherever it is equal to 0 would be also critical, because it is equal to 0. Let's go that also the endpoint right there, because it's equal to 0. Critical points occur when G prime of X is equal to 0. Whenever G prime of X is equal to 0, and even though it's an endpoint, it f of X is equal to 0. Whenever the velocity is equal to 0, and we are saying that this is, let's say it's velocity, then it's equal to 0. So whenever it is equal to 0. So this is important. So why? Justify your answers. Well, the critical points, if you're given the velocities, where f of x equals 0, which is g prime of x. Okay. Where's g increasing? Where is g increasing?
0 to 4.
From 0 to 4, because why?
F is positive. Greater than 0.
0 to 4, and then what else?
6 to 7.
6 to 7. No, I'm trying to get away from this union. It's better to just kind of do comma from 0, including 0 to 4. Increasing, you do include. They would accept 0 to 4 open, but when you're talking about increasing, decreasing, just do these brackets for whatever, and then comma that. And we're saying because do we say f prime of x? Oh, no, what the heck is f of x is greater than 0? That's what we're saying, no? F of x is greater than 0, and then here. Because okay, now make that connection. If we're talking about g and we're talking about f, make a connection g prime of x, which is equal to f of x, and both of these are less than 0. Just you know, on the AP exam, just kind of remember that. They will probably maybe dock points if they're going to say that, or you didn't put the connection between the two. So where is it decreasing? Where's g decreasing? Where's g decreasing? Anybody?
4 to 6.
From 4 to 6, because why?
G prime of x.
Which is equal to f of x is less than 0. Okay, continue on. Let's continue on. E, let's go to E. Find the x coordinates. Find the x coordinates of the points of inflection of G. Then identify where g of x is concave up and where is it concave down. So, what are the x coordinates of the points of inflection of G? Anybody? 2 and what?
5.
2 and 5? Now, okay, yes, all right. Let's see. Why is 2 and 5? Why is it 2 and 5? F prime of x changes signs. Yes, yeah. It has to change signs. That is correct. So, is this somewhat? Would this be a candidate? Would that be candidate? Would it even be a candidate for it? It wouldn't be a candidate because it doesn't change signs, no? So G double prime of x, which is equal to f prime of x, is equal to 0 or does not exist. Okay, so here's again the definition. We have to find where f prime of x is equal to 0 or it does not exist. F prime of x does not exist. This. If we're looking at graph of f of x and do the derivative, because there's a corner there, it doesn't exist, so it's a candidate, because that's what it says here, no? So this is important here. But at the end of the day, you notice that it has to change signs, and it's not changing signs there. So two, 4, and 5 are the candidates. And the inflection points are at 2, 5. X equal to 2, x equal to 5, because at those points the graph changes signs. So you have to really make that distinction, no? Between when do you say that something changes signs and what else? And something is positive, or it's less than 0, greater than 0, those kinds of things. Concave up means that g double prime of x, which is equal to f prime of x, has to be greater than 0. So concave up will be, where will the concave up be? Where? We're now answering the concavity of it. We've answered the inflection points, now we're answering the concavity. So where is the concave up?
0 to
From 0 to 2, and where else?
5 to 7.
5 to 7, because it's the slope of this positive. G double prime of x is equal to f prime of x, greater than 0. And from 0 to 2, and 5 to 7. And concave down will be what? What do we say on the concave down? Do we have to say from 2 to 4 and then 4 to 5? Or do we say 2 to 5? 2 to 5? Two to 5. Better be 2 to 5. Now the question is, would this be wrong? I don't think so. Why would it not be wrong, would you think, if we say this? I don't like this union thing, because this guy in the Facebook group, he says, don't do unions. Anyways, 2 to 4 and 4 to 5, would that be wrong, or could we just say 2 to 5? Man, how can we justify it? It did not change signs at 4. what are the things that we have to satisfy here? Find, that's for points of inflection. Find where this does not exist. That's a question. That's a question that we got to answer. Why exactly is it? Is this a problem here now? Is this a problem? Because the velocity, no, it's not velocity, it's what?
Acceleration.
The acceleration is equal to what? The rate of change of the velocity is less than 0. G prime of x, which is the not equal to 0, we have no problems here, no? We have no problems anywhere here because that's negative, it's negative. No problems here because this is negative. But what's up with that then? What do we say about that? What are your thoughts on that one? Huh? What are you going to say? What are you going to say to you? All right. What is F? What is this? What did we say it was? What is it? What is the graph of that? It's velocity, isn't it? And what's the velocity at 4? And what is it that it's saying that it's saying equal to it? But if that is in fact true, then it shouldn't be, what's the velocity at 6? Well, then it shouldn't be, we're saying from 4 to 5? Oh no, we're talking, where are we at? Where are we at? The concave up is, we're saying here, concave up what? Between 5 and 7, no? 5 and 7? Well, if the velocity is 0 here, then it shouldn't, no? Huh?
Well, that one's talking about F prime. So, just a slope.
Where? Which one? Where?
Because we're talking about how F prime has to be less than 0, not F itself.
Just this has to be less than 0? On which one? Hold on. It's just the slope of it.
Yeah.
So what do we say then? What is it? Not the actual velocity, but the slope of the velocity. The slope of the velocity, not the actual velocity. Just in case they throw something at on a test like that, what we do. Man, I gotta ask what the, if we can say two to. I think I do remember looking at this on a question on the AP people talking about what is it? Where's the concave? Is the concavity? Is it from here to here, or is it here union that to that? I forget what it was. The answer to it. where was it? I have to ask somebody exactly what that should be. What are your thoughts then? What do you think, too?
I think that one sounds better.
This sounds better? Just don't mess it up. Just they give you a question like that, and they're like this, and then they give you like that. Because we're not including that 4, no? Because of f prime of x, find where f prime of x does not exist. We'll go back to that later and just try to answer that better. Let's finish f. I have to really meditate to really get to the bottom of that. Identify the x coordinates. Identify the x coordinates of the absolute max and absolute min of g of x. Justify your answers. Where's the absolute max and absolute mins? Where's the absolute max and absolute mins of g of x? What are the conditions for that? For sure, what are the x coordinates of the absolute? Oh, it's talking about absolute maximums and absolute minimums. We need to find the graph of this. Where did it start? What was the function? It said that what? G of x was what? G of x is what? Integral of what? From where to where is very important. From where to where? Huh? 2 to x of what? So we need to figure out what the position function is, no? The graph of the position function. If we're going from 2 to, we're starting here, no? We're starting here. Let me do my colors better here. Do this color. But we're starting here, accumulating. Okay, what did we say was G? Let's do G of negative. What's G of negative 2? What is G of negative 2? Oh no, that's one was G of negative 2 would equal from 2 to negative 2. Why am I doing negative 2? G of 0. G of 0, 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 and 1 2 of f of t dt. And what did I say? That eventually we're going to go to that one thing where we do what? Switch the bounds and put a negative in front of it, no? And we said that what is this area then going to be? We're going from there to there. What was it? To get 0. To get what G of 0 is. Say it's G. What is it? Negative, what is 2? This is 2 times what? 2 times 4 is 8. Negative 4 you said? Negative 4. That's what it is. The position of it is negative 4. Negative 1, negative 2, negative 3, negative 4. What is then? What is gonna be? Let's do G of 2. Well, we gotta test these critical points. What's another critical point we should test? What's another critical point we should test?
4.
And so at 4, let's do G of 4. G of 4 is what? G of 4, it would go from 2 to 4, 2 to 4 of f of t dt. What's that?
4.
That one's 4. It's somewhere up here, 4. It's a positive, it's 4. Oh, wait, here. I'm saying this is 4. It's somewhere up. It's 4. Okay, and we're up there. 1, 2, 3, 4. Somewhere up here. And which other one do we need to test? 6. And that one looks to be what? 6, that would be what? From here to there, this is what? This is, we said it was what? We said this is 4. And doesn't this, no, that's going to be what? Is that, huh? Negative 1, so it'll be 3. 3. So 3, no? So what's the absolute max? At where? So the max would be at x equal to 4, and the absolute min would be at 0.
We have to test 7 because it's an endpoint.
That is correct. We do. Why do we have to test it? Because the graph of G got to test endpoints, of course. No? Yes, let's test 7. What else? 7 would be. What is that one already? You're gonna add what? How much more? What the heck? Oh, a half. 3.5. 3.5. Almost, but not quite. It would, if we would have gotten something bigger, that would have been the max, absolute max. No? So yes, we do have to test those endpoints. Anyways, you want to test them with the table better. Maybe do it like this. Better. At x equal to 4, and the max value is 4. The absolute min at x equal to 0, and the minimum value is negative 4. Man, took the whole period. Let's go number 3. Let's finish this whole thing. Let G be the function given by blah, blah, blah. What is the x coordinate or the point of inflection of graph of G? what are we gonna do for this? Anybody, what should we do?
Get the derivative.
How many times? G prime of x, G prime of x will equal to, just plug in x for every t, so it will equal to x squared minus 5x minus 14. That's the velocity, no? We want inflection points. How do we want to find inflection points?
Take the second derivative.
G double prime of x, 5/2. We're really gonna do this one too. Let's go. Let's finish. The function g of x equal to that describes the height of a falling rock with respect to time. What is the velocity of the rock at 5 seconds? What do we do?
Get
G
G prime of x.
prime of x is equal to what?
Negative 9.8x.
Now what do we do?
Plug in 5.
Because we're already in the velocity, find out what it is, no? G prime of 5. Graph. And whatever that is. Now we're done.